Hey everybody, here is your first video. This video is going to be for graphing and interpreting functions. So the page that you would want to have in front of you as you're looking at things is in your toolkit, the list of all the graphs and the values that we used. So here we go. All right, we are first graphing a log, which is our latest section. So let's just first do the first thing that they're asking, which is to make sure we know what all the transformations are. Okay, so that means we've got a compress and we have down 3. So the first thing I'm going to do is go ahead and deal with my asymptotes. Since this is a log, I have a vertical asymptote. And that vertical asymptote is not going to be moving. It will be stuck at x equals 0. And then I'm going to move my starting point. So my starting point will not move left or right, but it will move down 3. So I'll be starting right here at that x. And then I'll go ahead and get my points. So as far as points go, remember here, what we do is we place our -2, -1 numbers in for y. And then we'll be using this 4 to the x to help us come up with the values on the other side. So if I start taking 4 to these various powers, anything to a 0 power is 1, 4 to the first is 4, 4 to the second is 16, and then the negative is just going to take these answers and move them. So it'll become 1/4 and 1/16. Now in this problem, we have dealt with the 3, okay? We've dealt with the 4 to the x, but what we have not dealt with is the half. So since we haven't built it into the table right away, we'll add it here. So I'm just going to take half of all of these numbers. And now I'll have a -1, a -1/2, still 0, a +1/2, and a +1. All right, I'm ready to graph my points. So starting 16(1) will not fit. So at this point, I'm just going to go over 4 from my starting point and up 1/2. And then I'm going to go over 1. And then I'm going to go over 1/4 and go down 1/2. And then I'm going to go over a 16th and go down 1 whole amount. So my points are really squished in there. So let's see if we can zoom in. Hopefully you can see all those points. My orange one got a little blended in there with the red. Anyway, this is growth. And the reason why I know it should be growing as I connect my points from left to right is because my base is 4. And that means if I keep multiplying by 4, my shape should get bigger. So here we go. It's time to do the arrows. So our first arrow that's not being stopped is infinity, infinity. The other arrow, x is 0, and the y is -infinity. And now we can answer the various graphs. All right, so our domain, small x, big X. Our range, small y and big Y. Here we're going to look at our graph for where x is 1, and that's right here. So my value for y, so again, this is saying if x equals 1, what is y? And y looks like is -3. And then I'm going to do 4. So 4, if you notice, does not, I don't know that exact point on the graph. So what do we got to remember is that we can always plug a number in to the equation if we can't see it on the graph. So that's what I'm going to do here. All right, so I'm going to take 1/2 of whatever the log base 4 is, and then I'll subtract 3. So the first thing I'm going to do is just get this log base 4 of 4 down to a number. And remember, I'm just asking myself 4 to the what power gets me back to this 4. And so this all becomes worth 1. So then I can take 1/2 times 1, which is 1/2. And then subtract 3, and when I do that, I get -2.5. And if you look on the graph, that looks like I went down. If I'm over at 4, it looks like I went down 2.5. Okay, all right, next one. Here's another log problem. So again, let's identify our functions, give everything a job. So we're going to go up 2, left 7, and then we're going to flip. So let's go ahead and move our asymptote. Left 7, so we're going to have an x is depressed at 7. Or sorry, negative 7. Our starting point is also going to move left 7, but then it's going to go up 2 and be here. And then we'll have a flip, which we'll deal with in a moment. So let's go ahead and get our table going. We're going to use 2 to the x to make our table. So again, remember, fill in for the y's. And if I take these numbers to the power, I'll get 2 to the 0 is 1, 2, and 4. And then their fractions over here. And so before I graph, I need to realize that I have not dealt with this flip yet. So I'm going to come over to my table and make all of these opposite of what they were. So that'll become 2, 1, 0, negative 1, negative 2, and then we don't need these. All right, so starting, I'm going to go from my x over 4 down 2, and then over 2 down 1, over 1, not down anything, over a half, up 1, and then over a fourth, up 2. So I'm getting really close to that wall. All right, so normally with my base being 2, I should see my shape growing from left to right. But because of the negative, it's going to flip and do the opposite. So it should be going down or decaying from left to right. So let's go ahead and get this graphed. And then we'll take care of our arrows. So first arrow is infinity, negative infinity. And our next arrow is x for negative 7 and infinity. So my domain, small x, big X, small y, big Y for range. I'm going to do the average rate of change. So just remember, these are your x values. So we're going to put our x's in the bottom subtracting, our y's in the top subtracting. So let's go ahead and just fill in the negative 6, take away the negative 3. And then if I look at my graph, when x is negative 6, I have this y value of 2. So that'll be its partner in the numerator. Whoops. Let's fix that. 2 in the numerator. And if I look at negative 3, then I have 0 right there as its partner. And now I'm going to subtract my numerators. Negative 6 take away negative 3 is like negative 6 plus 3, so that's going to give me a negative 3. And then it's fine if you leave it like that, but I do prefer you to divide these two numbers because an average rate of change is typically over 1. All right, moving on to number 3. So still in our log chapter, we got to remember that we got a little base of e here. So first, let's move our wall, deal with our transformations. We're going to be going right 4. Oh, and just backing up to this one. I realize I did not write the asymptote here. X equals negative 7. All right, let's go here. Sorry. So I'm going to move my wall, my asymptote, to the right 4 times. So we're going to have x is depressed at 4. And then my starting point is going to move right 4 as well, but not go up or down. So as far as the points go, this is exactly like it was before. And in class, we talked about that E is about 3. So if you want to get more points, I would suggest you use 3 to the x, which is it's going to be somewhat close to e to the x. Anyway, anything to a first power is 1. 3 or e to the first power is 3. And if you remember, this is when I was saying ish. This would be 9-ish. And then here comes their fractions. Again, these are all close to those numbers, not quite. And the only reason why I'm suggesting that is because this is so new for us. It'd be helpful to have more points on our graph paper so we could see what the shape's going to look like. So from my starting point, I'm going to go over 1, 0, over 3-ish, up 1, over 9-ish, which won't fit, but then I can go over a third and down, and over a ninth and down. And you can see those points are really close together, and then I am ready to do this. Here we go. All right, go in for the arrows. First arrow, infinity, infinity. And the second arrow is for negative infinity. Here we've got our domain, so small x, big X, small y, big Y. Our asymptote is x equals 4. And then when you read this, I just rewrote it below. This just says when is your function positive, which is this stretch right here. So I will say, using my x values, from 5 to infinity. All right, let's go to number 4, another E, just getting used to this. So again, let's deal with our wall. We're going to go left 1 and down 2. So first just move my wall. So I'm going to have x's depressed at -1. And then my starting point is going to go left 1 down 2 and be right here. All right, again, for the points, same idea as before. And in fact, we actually can just use these points right here. There's really actually no sense in rewriting them. And the reason I don't need to rewrite them is because I still don't have a stretch or compress. So I can stick with these points and move them, starting from my new starting point, left 1 and down 2. I'm sorry, I'm looking at the transformations. Right 9, 1, 2, 3, up 2, and then over 3-ish, up 1. The only point that's actually correct is over 1, 0, but then I can go over 3rd, down 1, go over a 9th, down 2. So again, we're going to get that same shape. And then with the arrows, we got infinity, infinity, and for this arrow, we have -1, negative infinity. So the end behavior is already set up for you, and I left the x part blank. So if we want to start with the one that's simpler, we can put the infinity in, and I would be looking right here. So if x is infinity, what's the y that went with it? Well, that's also infinity. And then on the other arrow, I didn't have an infinity. So what that means is I'll put in -1 because x is getting close to -1, and while that happens, your g of x or your y is going to negative infinity. And again, our asymptote is x equals -1. All right, there's your first page. Let's start hitting the review stuff. So number 5 is actually from chapter 5, and this is where we had 2 shapes on there and we have 2 walls. So let's go ahead and deal with the transformations. So we're going to have a flip and a stretch from our numerator. We're going to go up 3 and right 2. So this one has 2 asymptotes. So here's right 2. So x is depressed at 2. And then up 3. And so y flies by at 3. So we can go ahead and get those here. X equals 2, y equals 3. Now I'm going to get my points graphed. So I use whatever a is over 1 to fill in my table. In this case, we've already dealt with the 3, we've already dealt with the 2, and we're going to deal with the negative and the 4 within our table, so we won't have to add a new column. So we said when we did this that we would use a, its opposite, 1, and its opposite. And these are all the x values that will go in. So I'm putting -4 in here, and when I take the -4 and divide it by -4, I get 1. So this would result with -1. And then -4 divided by the 1 here is -4, so the other one will result in a 4. So going from my new starting point right here, I'm going to go right 4 and up 1. Oops, that's not correct. Let me fix that. It's left 4, up 1, and then right 4, down 1, and then right 1, down 4, and then left 1, up 4. And remember, this is all shapes are curved like this. I don't ask about domain and range here, but just for the arrow's sake, this arrow we started with this arrow, if you remember. So x is infinity, y is 3. And then if we jump to its opposite arrow, then x is just negative infinity, with y being 3. And then I said you could go to this arrow, and x is 2, and y is infinity. And then you drop to this arrow, and x is 2 with negative infinity. All right, let's go ahead and go over the problems. So in this case, I need to see when x is 4, and I can't quite see what that is. And you are welcome to guess, but if it's not exact, then it wouldn't work. So the idea, again, if you can't tell from the picture, is go to the equations. So put 4 in for x and just simplify this. So that's going to become, the denominator will become 2, and negative 4 divided by 2 is negative 2. And then if I add 3, I get 1. And so could that have possibly been 1 there? Sure, because my graph isn't perfect. And then I want to know the x-intercept. So the x-intercept is when y is 0, and I still can't quite tell that on the graph. I think it's somewhere between 3 and 4, but in order to verify that, I need to go into my equation and make the y become 0. So that's how I do this here. So 0 equals this. And to solve for x, I'm going to subtract the 3 first. And now here, when you have a fraction equaling a fraction, probably the simplest way to do it is cross product. So I get negative 4, and that's going to equal negative 3 times all of x minus 2. So I'm going to distribute first. And now I'm going to subtract my 6 over to join the negative 4. So it leaves me with a negative 10. And then I'm going to divide by negative 3, and when I do that, I get x equals 3.33. So is it possible that this point right here is 3.33? Yes, it sure is. So 3.33 comma 0 is my x-intercept. All right, back to first chapter. We are graphing piecewise functions. So if you remember, the first thing we talked about is realizing that we're going to graph pieces of each function, not the whole thing. And each piece is going to be expressed by their domain. So I'll have something left of negative 2. That'll be the negative 5. I'll have something in between negative 2 and 3. That's going to be the 2x minus 2. And then on the other side, I'll have the x, which I wanted to remind you, whoops, this should actually be y equals 1x plus 0. All right, so y equals negative 5, super simple, nice flat line. We'll have an arrow on this side, and here we'll have the open circle because this is not underlined. And then for my negative 2x minus 2, I'll start with negative 2. It's my y-intercept. And then my slope, my rise over run, is going to be up 2 over 1. Right below that. So I'll connect those. And then because this side is underlined, make sure that's closed. And then on the other side, make sure that's open because it's not underlined here. And then my last one, where y-intercept of 0. Now, do not put it on the green lines. The y-intercept of 0 is here. And then I'm just going to go up 1 over 1. And even though I'm putting a lot of points on here, I only need the ones here. And so I don't think I'm going to erase the other one just because it's, well, I can maybe get rid of a few of them. So let's fix that now. All right. This one will have a closed circle right below it. Let me make that in blue with an arrow on the end. All right. Let's go to 7 and 8, and then our last two for the graphs. All right, so this is our more recent chapter. This is exponential. So let's talk about the jobs. We're going to have a compress. We're going to go right 3 and down 2. And so this is exponential. So if you look at your little page, you know, this is where we have horizontal asymptotes because there's so many flat lines and an E. So I will go down 2. Whoops. Right, down 2. And I'm going to have a y flies by at negative 2. And my starting point, though, is going to go right 3 down 2 and begin right here. So as far as points go, we're back to these numbers on the left side. And in this situation, we have a b of a half, so we'll begin at a half, not ideal, and it'll grow by 4. So we're going to begin at a half, and then I'm going to start multiplying by 4. So half times 4 is 2, 2 times 4 is 8. And so basically what happens the other way is I'm going to divide by 4. So that'll become 1/8, and divide that by 4, and I actually get 1/32. All right, so let's go ahead and get this graphed. So from my starting point, I'm going to go over 2, up 8. And then, let's see, over 1, up 2. And then I'm going to go over, or not over, but just, let's zoom in a little bit, like up a half. And then over 1, barely up, over 2, up even less. And this should be growing because we're multiplying by a half. And if you realize, I didn't change the y values because I incorporated the 4 and the half within my table. So here goes my shape. As far as arrows go, this one is infinity, infinity. And this arrow is, what is it, negative infinity, and then my y flies by a number of -2. All right, let's start with range. Small y, big Y. My asymptotes are y equals -2, that's it. And then we got another average rate of change. So these are the x's, 4, take away 5. And then I'll need their y's. So if I look at the graph when x is 4, I got a 0, so I'll put its appropriate 0 on top. And when x is 5, I've got 7. So when I subtract, I get -7 over -1, which results in just a positive 7 over 1 once I divide. And our final graph, so number 8. It is an exponential function, so we can start with these points. But before I jump ahead, let's talk about our transformations. We're going to have a stretch of 3, left 1, down 4. So my horizontal asymptote will be moving down 4. So I'm going to be y flies by at -4, and my starting point is going to go left 1, down 4, and be right here. All right, so again, you are welcome to use all of these points, but B is 3, and G is E, so about 3 as well. So I'm going to begin at 3, and then if you want more points, then we're going to multiply by 3-ish. So this is 9-ish, 27-ish, 1/3-ish, 1/9-ish. So from my starting point now, we can do, let's see, over 2 up 27 won't fit, but over 1 up 9-ish. About there. And just up 3. And then over 1, a little bit up, over 2, up even less. So we got another growth. Let's connect these like that. All right, and again, they're not asking for domain and range, but this arrow would be infinity, infinity, and this arrow would be -infinity with the y value being -4. So my asymptote is that y flies by -4. Here I want the y-intercept, so that's where x equals 0. Okay, so if you notice the directions here say leave in the form of E, that's because this point was an ish number. This point is the only number that I really knew. So as far as this point goes, I'm going to have to do this a little differently. So I'm going to go back to my equation, and y-intercept x is 0, so I'm going to go to the equation and put 0 in for x. And then I'm just going to simplify this. And when it says leave in the form of E, just simplify it as much as you can without using the calculator, basically. So this becomes e to the first. And this is it. Like, now, at this point, if you want to type this into your calculator, you could. But I am also okay if you don't. Let's see. I didn't do that. Let's find it, though. So 3e. It's about 4.155 if you really want to do that. So again, 5-ish, that's 5-ish. It's more 4-ish, but it's close enough. All right, that is your graphing portion of your final review.